Hello, everyone. Very great to see you all, and thanks so much for your precious time you're sharing with me. Hi, Tim. Yeah, I'm David, founder and CEO of Neura Robotics, and I'm here to talk a little bit about my personal vision and at the same time also the mission Neura Robotics is on. And like the way we see the world also going forward in physical AI, and at the same time also what we think is a differentiator and in how we do things and what we do. So to explain a little bit about Neura itself, we are about 1,500 people based in the southern part of Germany, so in Metzingen to be precise, and with the aim of making robots cognitive. So it means give the robots the abilities to hear, see, and feel, and at the same time also react fully autonomously on different kind of topics and tasks. So the other claim I would like to do today is actually that I do believe that robotics or physical AI will take every physical task in the future. So it will actually do any kind of physical task. I know it sounds actually pretty big, in the same time for some people maybe a little scary, but I do believe this is the biggest chance we as humanity have today to actually use machines as machines while using humans actually as humans in the world, and basically making the next step of humanity. So the reason for today actually having this nice events, in the same time also a lot of people going crazy about robotics and seeing that as a actually like kind of a hype in robotics, is basically very naturally driven. So one, because we do see actually going further, like even in a very close future, that like we are actually facing one of the biggest challenges actually on humanity right now. So if you're looking into Europe, you will have about 7 million less human labor by 2030, while actually China has even a bigger issue, about more than 80 million less human laborers, while going actually also to Japan or US in about, let's say, 6 to 10 million less human labor by 2030. It means actually there is more people getting actually retired with skills than actually new people getting trained with new skills. And if you're looking actually a little bit more precise, then you will also see that the most people actually retire with skills are actually in the space of physical task and work, while actually the new people with skills getting trained are not in physical. So the most people don't even want to make this task anymore. And this is actually why the physical work will actually require like a new solution, some technology which can actually take over and basically bridge the time, at the same time also one day take over the whole task. But the other, I think, even more important KPI we are focused on is actually the time to skill. Because the reason for physical AI and robotics actually taking over every physical task, it has something to do actually with the way of how humans are getting trained for physical tasks. If you're looking into the lowest value bringing work, so it means tasks which don't require any quality dependencies or any, let's say, special skill sets, here, like we are talking about, let's say, not less than 3 hours of instruction and training time for a human to change a department or start a new task in the work or new work. And if you're looking into actually robotics, and this is also the core part we are focused on, you will see actually that even today already, there is possibilities like of training a robot for, let's say, for a new skill in less than, let's say, a couple of hours, instead of actually weeks, months, or years like humans do. And the other big advantage we have is that, like, the good thing about robots and physical AI is that you have like a new vessel for knowledge, or so it means, and the good thing is that you can transfer it by one click, while a human needs to learn it again and again. Every time a human retires or changing work, changing the job, or actually getting sick, you can't just click on something and have the new skill actually transferred. And this is actually the case in robotics. And this is also why we are seeing that in the future, in the very close future, there will be no, let's say, how to say it, it will not make sense to actually use humans for all the physical tasks and train them for new tasks, because there is actually robots much faster, and physical AI especially. And then I would like to also talk about another topic we are focused on right now a lot, and because today we hear a lot, okay, is actually hardware not commodity already? Like, and do we not have to focus just on the brain part mainly? I think that most people would agree, but here I do need to say, like, it is not the case yet, but very soon. So, and what I'm talking about is actually building a hardware which is capable to send actually the right data to actually a compute infrastructure to create the right knowledge. And here I love to make that example of basically swimming, because this is the biggest differentiator of like a vision language model to what we call perception language model, a model which is multimodal, and it basically receives more than just vision data. And why is this important? It's like, and that's actually where I love to use the swimming example, is because like with swimming, you can't learn the most of the physical task actually just with your brain. And you can't just basically watch a video for a year, 2 years, 5 years, whatever, and be a swimmer afterwards. And the reason for that is very simple to explain. It's not just, how to say it, because you can't learn everything with your brain. There is more actually what a human has. You're going into the water, and then you're actually training something else than your brain. It's actually your nervous system and the reflexes of your body, so of your muscles. It's actually a memory effect of your muscle. So and this is also applying for the most of the task in the physical world. Everything what's moving, everything what's flexible, everything where you have to react on, you're using more than a brain. And this is also something what we are right now mainly working on, is like not building on an existing standard, but actually setting a new standard for that we call smart limb concept. So what we build is actually like first, yes, you're having a brain. And then the second, actually, you do have a nervous system. Here we're working also with Qualcomm on a solution for that. We call it like limb concept because it has 7 limbs, like a nervous system, which is super reactive, and at the same time trainable for actually abstract training, we call. It's like you're gaining some knowledge into your body while actually having not, how to say it, not making decisions, but actually very fast reactions on the body set. So if you have everything like that in place, then actually a new thing, the issue appears, and this is basically also the data sets, because I think this is something we hear here all the time, is about the data, which is not existing yet. So first of all, I think very important to mention, it's not just about having physical data somehow, because this is what we hear and see right now a lot. I get a lot of messages, hey, we have a lot of data, you want to buy it? Here is, I think, very important what kind of data and where does it come from. So, and for that, you first need to define, as I said, like the sensorization, because that's where the data come from. And then basically having the right compute infrastructure to enable actually this, let's say, thinking of brain and actually having a reaction of the nervous system. And how to train that, and this is something where we are right now mainly focusing on. It's also why we raised a lot of money for, is basically building the infrastructure for physical AI. And what I mean by that is actually real physical places where we place, let's say, 100-unit humanoids, or different form factors if you want to, and in the same time giving everyone the tools instead of the solution. So it means having a platform we call Neuroverse, where you can find the tools so you don't have to have the knowledge about how AI is created. You just have a start record button, by manipulating actually a task, stop, record button, and then the third actually train. And what you do with that is actually you're fine-tuning the foundation model we built, actually to give them a special knowledge. And this is also one of the other core differentiator of what we are building, is basically, we call brain account. It's actually that we don't want to, let's say, commoditize basically the knowledge, as everyone tries to do, as we did actually with Anthropic and with OpenAI right now. You're having basically a brain which knows everything. It sounds also pretty good, but in reality, it brings also a certain impact, like to especially this one, which are basically, how to say it, where they took all the knowledge away from. Right? And if you're looking into the physical AI space, I think it's kind of danger to just say, like, we are here to build one brain and train one brain which can do everything. Because it doesn't make sense, because the reason for all existence of all the companies is mainly behind the knowledge they have and how do they think. I mean, in process knowledge and also know-how knowledge, how they actually do things different to others. So this is also a differentiator of what we are building to others, is basically we're enabling everyone to actually have their own brain account, basically a fine-tuned model of their knowledge of how they do things, to actually also in the future having the possibility to monetize it and actually license it to the world, because this is how we see the world going further. I don't think it will be like it is today, that you're having your physical company and like Foxconn or whatever. I do think these companies will have basically a brain account which is pretty capable, and they will license it to you, so you have your possibilities to do the same production capabilities as they have in Taiwan, in China, and whatever, but actually on your place in your factory. And this is also, let's say, what we are mainly right now working on, is actually first building the foundation model to give like all the general knowledge to the robot of how does the physical AI, let's say physical world around you actually interact. Like how does everything move? How is it dynamically different? How do you move things that they're actually, how do you correct them? How do you react on things? This is a task which we are doing today. This is very general. And at the same time, what we are doing is basically also getting a lot of data out of humans. So we are having about 1,000 employees in data suits where we are gaining a lot of data, surely with actually the human-robot disability gap, but actually combining that with real-world, let's say, physical data out of the robot with all the disabilities, you're actually enabling like a very smart device. Again, it is capable to do general things, as mostly humans are. So it means actually, so why is this so important? And why do we think this is the way how we should do things? Is that this is how the physical world works, or the industrial world works. Even you're the best expert in actually manufacturing, believe me, if you're coming now to my fab and try to start to build one of my robots, even you're the best expert, you will not be able to do that. So, and the reason for that is actually that there is a little general knowledge in every of the companies which we want to actually bring on the platform and actually into this brain accounts of everyone. And then the other claim I would like to do today is actually it is not enough to just have a smart robot. Because this is actually what the world works right now on, is like making this robot as smart as possible. It's the same happens also in the autonomous driving industries. You're trying to make the car as smart as possible. And believe me, this is not a solution. This is not how it will end up. And this is also what we are working on. Through the Neuroverse platform, you're adding another layer, which is the layer above the robot. So it means the orchestration layer, a layer which is actually orchestrating everything around you. A layer, like to explain it to you faster, it doesn't make sense to have a robot walking up the stairs to open the fridge to see there's nothing inside, while actually having a layer above, which is connected to the fridge, and actually tells you already the right information, orchestrates actually the whole world around you. This is what we call Neuroverse. This is also something we just presented 2 weeks ago in US again on the Automate, where we shown actually you can simply have like a chat and you talk to, and everything around you actually get adjusted and actually taken care of, because there is a brain behind everything and orchestrates everything. So what I mean by the platform Neuroverse, this is actually a platform we build right now. It's also a developer environment, so it's not just a platform which can do everything, but it's a platform which enables you for being able to do everything. So it's basically a communication layer between devices, at the same time actually devices to sensors, sensors to AI models, and at the same time also even the whole infrastructure. So we do believe that the platform we are building right now will also one day connect every autonomous driving car with a traffic light, with any cameras on the street, because they are bringing the right information to actually give you, let's say, a safe driving and a safe environment, and not just a smart robot. At the same time, this is actually also the marketplace we built to actually enable, basically, everyone to distribute their knowledge into the world, actually, and connect the world in that sense. I don't think the video will make a lot of sense now to show, so I will just basically come here to an end. So to give you a little bit of what is Neura about? So the most see us as a robotics company. So yes, we do build robots. Why we build robots? The simple reason is we do need to define a hardware which sends actually the right information to the right compute. So we define also the right compute to actually enable physical AI being real, so it means reactive on the real world. And then what we are building is actually also, let's say, a distribution network, basically a platform above of all them, which is connecting all devices and also let you distribute basically all your knowledge to others. So everyone has basically, how to say it, a solution for the future while not being an expert. So this is where we see physical AI going and what we basically build in Metzingen out of Stuttgart. So thank you for your precious time. And yeah, looking forward to meet you all. So thanks.